So far, Dhira and Saket, you can follow whatever I'm saying, right? I'm not speaking way too fast or my accent is not bothering you.
Yeah.
It's okay? Okay, alright. Hello, Saranya. Okay, so what we are going to learn today. So there's a WhatsApp group where most of the parents and some of you are also there, where I post what we are going to learn on a given day. So right in the previous class, we started talking about circle theorems, and that is where we talked about arc length, sector, and central angle. And then we started doing certain problems around that one. So what we'll do is, we will practice few more problems where I would probably try taking a nap, let you guys deal with those problems, and then I would want to hear how you guys are approaching those problems. It's not about answer being right or wrong, it's more about the approach that we are taking for solving any problem, okay? So just for everybody to refresh their memories, when we talk about circle theorem, we are essentially talking about a circle. Everybody knows how to find out the perimeter and area of a circle, no question about it. I'm assuming my statement is holding true so far. Everybody is clear with area. So I'm assuming everybody remembers. Come on in, brother. Come on in. See, the class looks so empty without the kids. All right. And if you guys feel cold, let me know. I can turn on the heater. Okay. So I believe everybody remembers how to find out the area and perimeter of a circle. What exactly it means. Perimeter is nothing but the length of the entire boundary, and area is the space it takes on the surface where you're trying to draw it. Now when it comes to arc is nothing but a portion of the entire perimeter. Yeah. So that's what we learned. Now how do you define the arc? This is the center of the circle. Join these 2 points. So any 2 radius that splits the entire perimeter into smaller pieces. There's one small piece here and there's a big piece here. So these 2 radiuses are the culprit, which is actually splitting your perimeter into 2 parts. Yeah. So these 2 radiuses are splitting this perimeter into 2 parts, or the circle into 2 parts. So this is the this is the minor part of the perimeter. It's called minor arc. This is the major part of the perimeter called the major arc. Similarly, this area, the shaded region that you see that gets created, or that split of the circle that happens, this is called your minor sector. The unshaded region we will call as major sector. Yeah. And so my arc is a portion of the perimeter. The sector is a portion of the area. Yeah. Everybody recalls that? And then these 2 radiuses that is splitting the whole arc or the circle, when you join these 2 radiuses with the center, this angle that it makes on the center is called the central angle. So you're looking at one central angle here, other central angle here. Is that digestible so far? Anybody? Dhira, Saket, as I told you guys, I will call out your names more often, but I'm hoping this is making some sense to everybody so far. Yeah? Jenna, Saranya, Vivan, everybody. Now, all that I have done here, I've just defined some terms. Arc, major arc, minor arc, sector, minor sector, major sector, central angle, smaller central angle, larger central angle. All that is theory. And this will be of no use if you don't apply them to actually deal with some problems. So yesterday when we were concluding the class, we had looked at one problem and we had paused it. I would want to go back to the same problem and see how you guys are solving it, because I kind of seeded that thought process yesterday. We just got started with what that problem is all about, and I'm sure all the kids who were there in the class yesterday would have started thinking about it. So this is the circle. This question says this is the circle. There is a point D and there is a point C on the perimeter, and this line is a tangent at this point on the circle, and this is your center. When you join these 2 points, okay, So this is your center O. You join O and C. Anyways, this angle is 30 degrees. I'm just writing down the question that we'll solve together. Okay. And this line, the center O and this tangent meets at a point A where it makes an angle of 30 degrees. And where it intercepts the perimeter again is a point D. Sorry, it's a point B. D is on that corner. So this question says, in the figure, point O is the center of the circle that we all can see. Okay, in the figure, point O is the center of the circle. Line segment AC is tangent to the circle at point C. As you guys can see, I was telling that at point C, this line is tangent to this one. And then OA equal to 12. O to A, this distance is given as 12. From this point to this point is given as 12. If the arc length of major arc BDC, major arc again BDC, this is the one. The arc length of the major arc BDC is, excuse me, A pi. The arc length of the major arc BDC is A pi. What is the value of A? Everybody heard the question? Now, okay, I'll not bother Praneeth. I've been doing that on purpose. But here, when you have a question like this to solve, read the question once, twice, thrice, analyze, come up with your plan, how you're going to solve it, and then you try solving it. That'll be our approach. Yeah.
You said something about line AC. I didn't catch that. Can you say it again? Did you say something about line AC?
AC is tangent at point C. Come on, Tony. Yeah. So Tony, you were there in the class yesterday, right? Yeah, you were there. So this is the question that we left, okay? I put that question on the board, got everybody confused, made everybody start bothering about it. Praneeth, can you shift a little bit to the right? Yeah, you can also shift a little bit so that when I make eye contact with you guys, then I can see whether kids have understood or not. Okay, so this is the circle. I'm just reading the question for you guys. The question says, O is the center of the circle. C is a point. We have taken a point C, and this line AC is a tangent at the point C. B is another point on the D is another point on the perimeter. And then you are joining this O with A, basically this line AC, and then you are joining O with A such that this whole length is given as 12 units, be it centimeter, inches, I don't care right now. And this angle is 30 degrees, and this is the point B where it is intercepting the perimeter. So we have been told that the length of the major arc BDC, major arc, of which this is smaller arc, minor arc, this is a major arc. It's given as A pi, and we have been asked to find out what is the value of A. Everybody clear about the question? I read the question twice for you guys. Dheera, Saket, you guys heard the question? Neil, Sarah, Jenna, Dave, Saranya. Yep.
I have a question.
Yes, beta.
We have to find the value of A.
Yes, because the question has a question in it. This question says that the length of the major arc BDC is A times pi. And now we have been asked to find out what is the value of A. You saying something?
Is A to O 12 or is it B to O? A to O, right?
A to O is 12. That's what is given to us. Let me just make sure that I'm not reading the question incorrectly. OA is 12. That's what is given. I'm sorry, Beta? Yep. So, here's the treasure, okay? Whenever you guys are running short of pencil pen, you can grab it from here, guys. Ask for what is okay. So, is everybody giving it a try? At least thinking about it? Okay. Alright. Yashmita, are you clear about the question, beta? I'm randomly calling out names, okay? I'm sorry, beta?
Yes.
Okay, okay. If everybody has understood the question, at least got what the question is asking for, then you guys can give it a try. Everybody thinking? Okay, let not ring in your ears, okay? You guys, I'll let you guys do it peacefully. One clue I would want to give is apply understanding of trigonometry and geometry together. That's what this question is all about. Yes, Sarah.
What does it say if it's B, D, C?
It's called the major arc and its value given is A times pi. You have to find out the value of A.
Okay, thank you.
And this question is not meant for scaring anybody. This is a very interesting question, okay? It will kind of exploit all the concepts that we know about geometry and trigonometry to some extent. Deera, is this question bothering you, beta? A little bit. Okay. I mean, trust me. This is for you guys to explore your own understanding of things. Okay. I'll give you guys another 5 minutes, maybe not 5 minutes, maybe another 3 more minutes. Then I will start jumping onto it. Yes, Jenna.
Do you have to use SOHCAHTOA?
You can any and every weapon that you have in your armory.
Oh, okay.
Is mosquito bothering you? No.
It's my socks.
Okay. That's what I was wondering. Okay, I'll give you guys 2 minutes. Let me get one more weapon. Tony has that. There's one here also. If you see any unwanted creature near you, just spray this. Okay, what's going on now? Yep.
I got A equals 10.
A equals 10. Okay. Pranit is saying that he got A equals 10. Anybody else? Any thoughts? Any view? This is a very interesting problem actually. So Pranit, okay, let's jump onto it, okay? Yes, Vishal, go ahead. You were saying something. No? Yeah, Vishal, you had unmuted yourself. I thought you were saying something. Oh, you also got 10? Okay. So, Pranit, can you try explaining me how did you get 10?
So, since we know AC is a tangent for this circle,
Mhm.
we know we'll create a 90-degree angle there because it's going to only touch it.
So, tangent, this is 90 degree. Okay, I agree.
So, that means we can use sine of 30, which would equal 1/2. So, sine of 30 degrees, which would equal 1/2. And then we can set, since we don't know what the opposite angle is, we'll set that to x over your hypotenuse of 12.
Mhm.
And then x would become your radius, and then once you solve that, you get x equal to 6. That's your radius. And since you know about complementary angles, you can find the central angle as 60, which is 90 minus 30. and then 360 minus 60 will get you the major arcs angle, and that will get you 300 over 260 times 2 pi, and then r would be 6. If you solve it, it would get 10 times pi.
Okay. So here's the deal. Can everybody hear me okay? So Praneeth kind of explained that pretty neatly, and I'm pretty sure Praneeth got that right. But my problem, I don't believe anybody. We'll do it together, okay? I'll do it in the simplest possible way. Right now, so this is for Dheera and Saket. We use this technique, RAN. Read the question enough, analyze, and then N stands for Nike, which says just do it. You have Nike today. Okay. Okay, so that becomes our approach. That's the approach I prescribe, and that's the approach that I also follow for myself. Meaning, when you have a question to solve, read a couple of times, analyze, make your mind, come up with your blueprint, and then you do it. Don't jump onto doing it. Now, that means we have read the question enough. Now, right now I'm analyzing. So, if I have to solve this problem, what is that we have to find out? We have to find out this length. And this is nothing but an arc. Major arc, minor arc, whatever it is. So, my whole perimeter is 2 pi r. Okay? And if I have to find out the length of the minor or major arc, any arc it is, if this is the angle I'm talking about, I have to find out this angle, and then I'll say that angle, let's say this angle is theta. Theta divided by 360 times 2 pi r. That will be my this length. Okay. Right now the problem that we are dealing with is we don't know what is this angle, and we don't know the radius either. That is not given in the question. Is that the same problem we all have right now? Everybody with me? Saket, Vivan, Ritika, Jana, everybody? Saranya. So, we all have the same problem. Had we been knowing this angle that these two radiuses are making, or the radius, angle and the radius, if we were knowing these two, it was easy to find out. We are given this value, but what is A we don't know. And this has correlation with this theta angle that these two radiuses are making on the center and the radius. If we find out these two things, it will be easy. Now let's see how we can find out the theta. So as Praneeth explained, this AC is a tangent on this point C. That means if I join this point and this C, this angle is 90 degree. And this angle is given as 30 degree. So if I know two of the angles and one of the side, that is good enough for us to find out this side. That's what trig functions help us with. Right? If you are dealing with only geometry, you will use Pythagorean theorem to find out the sides. If you know two sides, you can find the third side. Here, you have only one side and the angle is known to us. So that is where trig function plays a role and says, okay, I can help you find out the value of all the other sides if you know one of the side and one of the angle in a right angle triangle. So we know this side, which is, if I am looking at this triangle as a right angle triangle, this is the hypotenuse. Yeah? And this is the angle 30 degree, I'll call it as theta, let's say. So sine of this angle, sine of 30 degree will be equal to the side opposite to this, which is eventually the radius for us. Let's say radius by hypotenuse. Hypotenuse is given as 12. Now we all know sine of 30 degree is how much? Let's see, anybody on the screen who remembers what is sine of 30 degree? Who remembers the value of sine 30 degree? We proved that in one of the classes.
6.
Sine 30 degree. One more time. Yes, Vishal.
1/2.
1 and 2. 1/2. Yeah. So sine 30 is half. Sine 45 is 1 by root 2. 1 by root 2. Sine 60 is root 3 by 2. So on and so forth. Okay. And these angles you'll deal with so much so that you will end up memorizing it. Okay. Saket, Dheera, Jana, everybody with me so far, right? Vishwa, Jaspita. Okay, so now we are looking at only this triangle right now and we are trying to find out the radius. So that way, out of the two problems we are trying to solve, at least one will be solved. Yeah? So now, this radius is how much? This radius by hypotenuse I mean this side by hypotenuse will be equal to sine 30 degree. And as Vishal said, sine 30 is 1 by 2 will be equal to r over 12. That means r will be equal to 12 goes to that side, becomes 12 by 2, that is 6. So we got the radius as 6. Is that acceptable so far? Tony, with me? Everybody? We got the radius. So one problem is solved. This one we got. So pi over 360. Sorry, theta over 360 into 2 into pi into r. I can replace r with a 6. We are a little better off now. Now what is this angle theta? If you know this angle 30 degree, this angle 90 degree, this angle has no choice but it will be 60 degree, correct? That is how sum of all the three angles will be 180, correct? Everybody with me? Dheera, Vishwa, everybody? So now if you know this angle is 30 degree, this angle will be how much? 360 minus 60, that is this is 300 degrees. Now this angle is 300 degrees. So 300 by 360. 300 by 360 into 2 into pi into 3. This will be my total length of the arc.
It's not 386.
Thank you. Okay? Yeah, this is 6. So this is my length of the total arc, and that is given as a into pi. So from this, let's do all the funky stuff to find out what is the value of a. We have come close to getting the answer. So 360 by 300, 300 by 360, I'll knock out the zeros here. Then I'm left with 30 by 360, 30 by 36, so which eventually becomes 5 by 6 into 2 into 6 is 12, pi equals a times pi. So if I keep only a on one side, move everything to the other side, it becomes 5 into 12 pi by 6 into pi. This pi comes down, this pi, tic-tac-toe, 6 times 2 is 12. So a equals 10. Yep. Is this sounding okay to believe? Ria, Neil, Sarah, Vishwa, Rasmita, everybody? Jana? I mean, I'm just trying to make sure that I'm not teaching myself, okay? Tony, okay? Are you able to relate? So, see, this problem, I'll be very honest with you guys, okay? When I looked at this problem, I was also thinking, how do we go about solving it? And then we started peeling off the onions. Okay, what do we need for finding this arc length? This is what exactly we learned yesterday, and today we revised also, that if I know the angle, we'll say, okay, this angle by 360 degree will give me the length of this arc. Yeah? And the 300 by 360 degree times the whole perimeter will give me the length of the arc. Now, for us to be able to solve this, we need to know the radius, which we didn't know. So this radius I can find out from this right angle triangle. If we can find out the radius, this angle is known, this angle is known, this angle I can find. If you can find out this angle, we know what will be the remaining, this large angle. So that's how we just decoded it step by step. There's nothing complicated about this problem. It was just about how do we break it down into smaller pieces and make the complex looking problem an easier problem. Is everybody convinced about how we approach this problem? And now I can trust Praneeth and Vishal also. They said a equals 10, and I was not wanting to jump onto it and say yes, I agree. And that's a very big problem that I have, that I don't trust anybody when it comes to solving mathematical problems. And I'm doing it on purpose. There's nobody in the class whom I don't trust. Okay? But then the message that I'm conveying to you guys is, if you have a problem to solve, you are the best judge to evaluate, solve and agree to a solution. Don't go by what your best friend says. Is that okay? Alright, so let's move on. So again, with respect to arc length, with respect to sector with respect to central angle and all those stuff. This was one of the most complicated problems that you will come across. All the other problems that you'll deal with will be much simpler, easier than this. Okay, so you have dealt with what you can term as a complex problem, which is actually not complex. It's all about just breaking it down. Agree? Okay, all right. So let's move on to the next problem. Okay, and except Saket and Dhira, we have gone through a little bit of unit circle also, and we have solved some problems. Are you comfortable, Beta? You are comfortable? Okay, okay. So we have gone through the basic concepts of unit circle also, and we will apply that as well for solving some of the problems. So now we are not looking at the concepts in isolation. We are talking about, we saw a problem that we have to solve using geometry and trigonometry both. Now we are going to look at some problems where we'll apply the concepts of geometry, trigonometry, and also when I'm talking about trigonometry, I'm talking about basic trigonometry with right angle triangle as well as unit circles. We'll see depending on what kind of problems we are coming across. Is that okay? Yes, Smita, all okay? Vivan? I'm just reminding you as in between that everybody is okay with whatever we are doing, right? Okay. Now let me look at some more problems. And we'll try solving it together. The same approach. I will give you guys some clue. I will let you guys break your head with this, because it's not just about me solving 10 problems and saying, okay, we are done. I want you guys to do some problems and ask me questions wherever you are getting confused. So that way we agree on certain approach and make sure that at any point in time when we come across any problem, mathematical problem obviously, we know how to approach and get the jump start done. So this is a circle, and I'm making you guys believe what I'm saying right now. So there's a point C here, there's a point A here, okay? This is your center which is given a name E, and there's a point B here, okay? Now this length is given as 6, okay? And then you're joining E and C. It's I'm now reading the question, okay? And then if I'm extending this line further, this meets at point B. So you're seeing a circle here. Let me shade it also. That's how the question is. Now I'm reading what is the narrative that we have in the question. It says the circle shown has a center at E. The radius of the circle has a length 6. And the area of the shaded sector is 42. Area of the shaded sector, this one is 42. What is the length of the arc ABC? What is the length of the arc ABC here to here? Everybody heard the question, and again, complying with my commitment to you guys that when you have to solve a problem, read the question again and again. So I'm reading the question one more time. This is the circle that you see on the board. It says the circle has a center at E. The radius of the circle has a length 6. And the area of the shaded sector is 42. What is the length of the arc ABC? Talking about this length of the arc. So I'll let you guys break your head with this. And again, no new concept. You have to just recall what you know, how you relate. Get your hands dirty like the way you see my thumb being dirty. It's okay. Don't. I'm just curious to see how the kids are attempting the problem. And when you guys are ready, let me know. I'm just curious to see how you guys are solving it. Saket, Dheera, Vishal, Saranya, Sara, Neil, anybody? You guys are clear about the question and you know how to approach it, right? I think it's all about the calculation that you're doing right now. Okay? Dheera, you're clear with her? Okay. Good. Time for me to relax. Good, see nothing? Yeah. Jenna, how difficult you are finding this one? Or this is looking easy? You're just doing calculation right now.
I'm just trying to figure out how to start.
How to start? Okay, yeah, I'll let you think bit, okay? I'll come back to it. It's not a difficult one. Again, if I had to give a clue, I'll say that okay, this sector is nothing but part of the area of the circle. And then you can relate to it. Okay? Yes, Neil.
So we're supposed to solve for ABC?
Yeah, length of the arc ABC.
So not the shaded place or like just
See, no, so ABC if you are looking at it, right? So it says ABC, that means this length of the arc. That's how you have to read it, okay? Because, see, if there is a D, point D here. If you have to find out the major arc, it would have given you the name ABC, okay? Yes, somebody raised hand. Now? Done, Praneeth? Still doing it? Okay.
Is it 12?
Is it 12? No, you will tell me this is the answer, okay? How you found, we'll figure it out. It's okay. I want you guys to be more confident than me, okay? Okay, let me pick your brain. So tell me, how did you get 12?
I divided, I multiplied 6 because it's 6 here and 6 here, and it should be 6 here and 6 here, and if you add it, it will be 12.
Not that way. You'll have to look at this. This is 6 and this 6, obviously. Both are radius. So what you have to do is, you have to find out this area is what portion of the whole area. Okay? And based on that, let's say this is half. I'm just making it up. Okay? If this area is half of it, that means this whole angle is 180 degree. It's taking half of the whole angle of the circle. What is the total area? You know the radius, you can find out the whole area. And that area, this area is what percentage of the whole area. Based on that, you can find out this angle. And once you know the angle, then it's easy for you to find the arc.
Okay, so this is 30
How do you say so?
because it's an acute angle.
No. So, see, from 1 degree till 89 degree, all is acute. Correct? Anything less than 90 is acute. So, I don't have a way to agree whether this is 30 or not. It could be different also. Yeah. So, yeah.
Can I check this?
Yeah, sure. So, okay, let me give you a clue. So here, you know the radius. So
Yeah.
if you know the radius of something, your area is pi r square, which is pi into r square. Okay, so Praneeth and here, both of you, since you both are doing it together. So first thing you are doing is finding out the area of the circle because you know the radius, pi into r square, that is 6 square. Tony, you can also see. So this is 36 pi is my is my area of the whole circle. Now I'm trying to find out this is what portion of the whole circle. Yeah. So this is 36. This area is given as 42. So 42 divided by 36 pi. This is the ratio of this area versus the whole area, right? And from that you can find out. So now if this area, okay, again you can relate it with the arc also, because if this ratio and this ratio, I mean this one and the whole thing is in this ratio, the arc and this will also be in the same ratio. So this will be equal to this times the total arc. Total arc will be how much? 2 into pi into 6 arc is the total arc. 12 arc. 12 arc divide 12 pi arc. Sorry, 12 pi into this will be the arc length. Okay. 12 times 3 is 36. Pi and pi gone. 3 40.
That's bigger.
That's what you got. Okay. Yeah. So basically, Tony, was I able to explain you as well?
Yeah.
Okay. So there's so much of silence. I know you guys are already tired of me. In the last class, I bothered you for 1 hour, and today again bothering you, right? But here, when you're looking at this problem, I would want you guys to get excited and challenge the problem. It's like you see a insect that you don't like. What you want to do? You would want to keep it away by finding a solution for it. Okay, so that insect doesn't come to you. Here the solution is, this is a problem. You can either say, okay, I don't care about math, or you will say, okay, let me find out how do I get rid of the scare I have for solving it. Okay, so whenever you see a problem, find out ways to solve it rather than avoiding it. Okay, because avoiding is something that we cannot do. Okay, all right. Anybody got close to being done with this? Davik, you have just 20 minutes to go. Okay, all right. So, anybody in the class who has been able to solve it or close to being done with this? Biswa, Vishal, Neil, Sarah, Sahit, not Sahit, Saket, Dheera, anybody? No? I hope everybody is doing okay. Dheera okay, beta? Dheera, Saket, Jina, Sarah, everybody okay, right? Ria has been super quiet. Jina is thinking. Okay. Ria, all okay, beta? Ritika, any luck with this problem?
I wasn't able to solve it.
I'm sorry, beta?
I'm still working on it.
Okay. Now let's work out together. I will, when I'm trying to solve this problem, right, I would assume certain things, and one of that is, I don't know anything. That's my first assumption. Hi, Davik.
Hi.
So, Davik, obviously you joined a little late, not a little late, very late. So,
Yeah, sorry, I forgot we had class today, and my mom made me join.
Saturday, Sunday, imagine one day when I forget about the class, you guys will come back with stick to my house, saying, okay, where the teacher disappeared, except for the kids.
I was sleeping, so.
No, it's okay. It's fine. No. So, but yeah, again, put an alarm for yourself, like I do for myself, okay? So here, the question is, we have a circle here. This is the shaded region for which the area is given as 42 and the radius is given as 6. We have been asked to find out the length of this arc. Let's think backward. If I had to find out the length of this arc, there are two things that I need to know. Okay? One is this angle and second thing is this radius. Okay? Let's say this angle is theta, which we don't know. So I'm saying this is theta, a variable. Now, if this is theta, then what will be the length of this arc? Theta over 360 times the total perimeter. So this angle is one portion of the 360 degree. So theta over 360 times the whole perimeter. Now how much is the perimeter? 2 into pi into r. Now we know the radius, that is given as 6. So this is what will be my arc length. So theta into 2 into 6, 12 pi by 30, 360. This is the length of the arc. And I cannot give this as an answer because theta is still unknown. So let's simplify this first. So this is theta into pi over 12 times 3. Theta into pi by 30. This is the best answer we are able to give with theta being unknown to us. So far this is okay? Yeah, everybody? Now let's find out what is this theta. So if this theta was 360 degree, then we were talking about the entire area of the circle. Okay? But theta is not 360 degree. How much is theta? If theta was 360 degree, then we were talking about the entire area, which is nothing but pi r square, and my r is 6, so 6 square. So when theta equals 360 degree, I am talking about 6 square, 36 into pi. This would have been my total area, right? But we don't know how much is theta. But we are given this area. So if this theta was 1 degree, then I was talking about 36 pi over 360. Okay? That is what pi over 10. If theta was 1 degree, then we were talking about this angle. But there is a different situation here. We know the total area and we know this area. So this area versus the total area are in the same proportion, right? Meaning theta over 360 degree equals this area, this is theta, this area is given as 42 by the total area we just found out, 36 pi. So from this we can find out theta equals, we have to just move this guy to this side, 42 by 36 pi into 360 degree. Are you guys with me so far? What did I do? I said, okay, this is the area given 42. Total area we found out pi r square, pi into r square. R is given 36 pi. Total area is 36 pi and this area is given as 42. So 42 over 36 pi is equal to theta over 360. Yeah. So from that we got theta equals this value. Now the arc length we knew that, okay, if you have to find out the arc length will be this theta divided by 360 times the entire perimeter, 12 pi. And this is what we had got from this thing, right? So now we have found value of theta also. Let's plug in the value of theta from here to here. So it's pi over 30 into theta. Theta is given as 42 over 36 pi into 360. Are you guys able to follow me so far? Yeah.
For that angle, it would just simplify down to 420 over theta.
Say it again.
The theta, right? It'd be 420 divided by pi.
Yeah, I mean, so probably I did not simplify it, so I've just kept it as is. So now let's take care of the things. This 0 and this 0 I can knock off. This 36 and this 36 I can knock off. This pi and this pi can do tic-tac-toe. I have 42 over 3. 42 over 3, that is 14. 14 3 is 42. So this 14 is nothing but the arc length. If I kind of take you guys back in the journey of how did we solve it. We were knowing this area, we were knowing this radius. If we had to find, and we were asked to find out the length of this arc. First thing we did, okay, if I have to find out the length of the arc, that will be theta, this angle theta, let's assume this is theta, which we didn't know so far. Theta by 360 degree times the whole perimeter, 2 times pi r. And that gave us a value of, let me not complicate things here, this gave us a value of theta into 2 6 are 12 by 36 into pi by 30. This is what we got from this whole thing. Okay, so this is the length of the arc we got. Only unknown thing was this theta. So now we are trying to find out the theta. Other information we had was this is the area known to us, and we can find out the area of the whole circle. This sector was given as 42, and this whole thing we can find out, which is pi r square, and r is 6. So 36 pi. 36 pi was the total area. So we said, okay, fine. If this was 36 pi, then we were talking about 360 degree. But if it is 42, how much is the angle we are talking about? So theta over 360 is 42 over 36 pi, the whole area. And from that we found theta equals this value. And we took this value of theta, plugged it into this one. Okay? So theta equals whatever value is here, we plugged it here, and from that we found theta into pi by 30, right? So we just put theta equals this value, pi over 30, and this is your theta. And this, after simplifying this, we found this length. This is nothing but your arc length coming from here. Okay, then we plugged in this theta value here, and we got this arc length equal to 14. Did I complicate it? I was juggling too much between the corners of the board, but did I explain it okay, or I got you guys more confused? David gave me a thumbs down and a thumbs up. I'm not sure which one to take.
I gave you a thumbs down because you said, did I complicate it?
Oh, okay. No, I need to be explicit, okay? I mean, if I assume that, okay, I'm doing wonderful, then you guys will start hating me soon. Saket and Dhira, did I do a okay job when it comes to explaining it, or I got you guys more confused? Okay. How about Jenna, Neil, Sarah, Ria? Everybody okay?
Yes.
How about Saranya and Vishal? Okay. How about Tony and Anika? Ananya, sorry. Anika is another class. Ananya. Yeah. Okay. But anyways, you had solved it as well. So your approach and my approach, did you find any difference where you would want me to fine tune my approach?
I just said, you know, the sector formula, x by 360 times pi r squared.
Yeah.
I just set that to 42, found what x is,
Okay.
plugged it into the arc.
Yeah. Alright. So it's see, basically when you're approaching or solving any problem, right, what you have to do is list down what you know and what you don't, and then how do you find out a bridge to navigate the unknown towards the known scenario. Okay, that would be our approach for solving it. Let me give you guys a candy for today, which is not sweet. So most of you have come across the unit circle concepts. We have talked about that in some of the classes. Many of you would remember it, some of you might not, and that's perfectly fine. What I'm telling you is, let me give you guys a table here real quick, okay? And this table, yes Jenna, you're saying something.
Are we supposed to memorize these formulas, like the arc length and sector?
So there are two things, okay? So if you have a circle, there's only one property that describes this circle perfectly fine, and that is radius. If you know the radius, if you're talking about a tiny radius, your circle is like this. If you're talking about a humongous radius, you're talking about a bigger circle. Yeah? I mean, this is not humongous, this is still cute, but yeah. Bigger the circle, bigger the radius. So basically a circle describes a radius describes a circle. Now the only formula that you would want to remember is this. The length of the perimeter is nothing but 2 times pi times r. And the area of the circle is pi r square. So what you are seeing is, when you are looking at the perimeter, this 2 comes here. When you are looking at the area, the 2 comes at the top. Okay? As long as you remember these 2 formulas, that will be enough. Like you guys would have memorized area of a rectangle is length times width, area of a triangle is half into base into height. Same way, this also you'll have to memorize. Obviously, you would not want to derive this, and I have not derived this yet. Okay, these are the basic shapes for which we don't have to derive the formula, but as long as you remember these, should be okay. Okay, and then you can relate it to the concept that a circle makes a 360-degree angle at the center. So if you're talking about one part of it, 120 degree, you're talking about essentially 1/3 of the whole area. And that is what is your sector. Yeah? Alright. Now, as I said, there is a candy for you guys, which is not sweet. And this is how the candy looks like. So I am putting a table of sine, cos and 10 values. Cos and 10 values. For most commonly used angles, 0, 30 degree, 45 degree, 60 degree and 90 degree. Okay? And sine 0 is 0, sine 30 is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1, and cos just reverses. You'll start from here. 1 root 3 by 2, 1 by root 2, 1 by 2, 0. And 10 is sine by 10, sine by cos. So 0 over 1 is 0. 1 by 2, this becomes 1 by root 3. This becomes 1. This becomes root 3. This becomes undefined. And this, though I am putting this table here, and Saket and Dhira must be thinking that this old man is forcing us to memorize this table. You'll end up memorizing it. You don't have a choice actually. But in our class, I don't give the numbers to memorize. So all this is based on what we have derived in the previous classes, and again we'll derive that in future so that you guys can refresh how those numbers are arrived at, how these values are arrived at. But this is not the agenda. The candy that I was talking about, I was saying, okay, you know these angles. Let's assume that you guys memorize it, because you will end up memorizing it when you deal with it a couple of times. But my question is different. I'm saying find out the value of 10 to 25 degree. How you can find it out? You cannot use SOHCAHTOA to have an angle like this. So you have to use unit circle concepts. How would you find out the value of 10 to 25 degree? Any thoughts? We have only 4 minutes. I want you guys to, instead of trying to solve it, give me some approach that you would want to consider for solving it. So Virat, you are here but you are not here. Yeah. So we have 4 minutes to go. Everybody heard the question, right? I said we are trying to find out the value of 10 to 25 degree. Yeah.
So you just use the unit circle. Basically, 225 would be 190, 190, and then another 90. That would get you 180. 225 minus 180 will get you an angle value of 45. So your 1045 would be 1.
Okay. 10 to 25 will be 1. Saket is giving me the answer right away. But what I'm trying to do here is this. So basically, I kind of get the approach that Prince was saying, and we'll talk about this in the coming class. But as I was saying, whenever you go beyond the angle 90 degree, you don't know how to deal with that using SOHCAHTOA. That is where you can rely on unit circle. Rudraj, you're not here yet, so I don't want to hear even a pin dropping. So here, when you talk about 225 degree, your unit circle says any point on the unit circle has a coordinate of cos theta comma sin theta. So if I'm talking about cos theta, that is my x coordinate, this length, and sin theta is my y coordinate. And this becomes a generic rule. That's what we have learned in the previous class. And we can come back to this again if there is a need. So if I'm trying to find out 10 225 degree, let's find out sin 225 and cos 225, and sin by cos will give me this value. So if I'm talking about 225 degree, I'm talking about 80 degree, 180 degree here, and then 45 here. Here, in this case, you guys gave me a 1, Saket was giving me a value of 1, which I'm not in a mood to agree to. Let me see. My sine value will be negative, and cos value will also be negative. Yes, Saket, you're right. It'll be 1. It'll be 1. So, but some of you who are still struggling to figure out how did I agree for this 1 or whatever is the answer, we will deal with this in the coming class. We will look at some of the problems and break it down in the simplest possible way, because my problem that Saket and Dhira are not aware of is that I am not intelligent, so I will not assume anything, I will break it down. And when we break it down, it becomes much more easier for all of us to agree to. Alright, with that being said, I will let you guys go, enjoy the rest of your evening, and I'll come back to haunt some of you on Monday, the Algebra 2 class, some of you on Wednesday, pre-calculus class. Yep. Alright, thank you, bye-bye.